Okay, so here's a little bit of extra video stuff for section 3.5 to kind of help you out. The first one, because we're going to do 2 days in this section. Most of the first day is solving for X stuff and a couple of small proof things. But yeah, let's take a look here. So we're going to find X so that M and N are parallel. This was the homework problem, so if you're looking ahead before class, you'll have this done. You'll have me walking through it. The key to this is recognizing what type of angle pair we have here. And what we've got is a pair of angles that are outside the two lines we're trying to prove parallel, M and N, and they're on opposite sides of the transversal, so these are alternate exterior angles. And the theorem goes that if these guys are congruent, then we would have parallel lines. So we're just going to set 4x minus 23 equal to 2x plus 17. Add 23, subtract 2x. 2x ends up being 40 divided by 2. X is 20. There we go. X is 20. All right. Next, from the first day homework things we'll do in class then. I really can't zoom in much more in this because it's that's okay. My not nice one. Okay. Yeah, that worked out okay. Let me do a little bit of auto-focusing on it. There we go. So the question is, are any of the angles lined parallel by given the angle pairs? If so, name what type. So 1, 3, and 7 in the drawing here. 3 and 7 are a pair of alternate interior angles. The transversals L, A, and B are the lines it's cutting through. So it'd be A and B, alternate interior angles converse. That is converse, believe me. Number 2, 9, and 11. 9 and 11 are a pair of corresponding angles. So it would be, again, for lines A and B, so A, B, corresponding angles, converse. Okay. Might just do this in pen if I'm going to zoom in this much. That's a little fat in there. 2 and 16. Here's 2, here's 16. 2 and 16 are on transversal A, so L and M is what we're talking about. And L and M for 2 and 16 are alternate exterior angles. And again, it's the converse. And then 5 and 12 add to 180. Well, 5 and 12 are a pair of consecutive interior angles for L and M. So consecutive interior angles. Okay. Now I'm not going to solve 5 through 10. I'm just going to kind of walk you through what to do. So 5, you have a pair of consecutive interior angles. So in order to make those lines parallel, add them together, set them equal to 180. On 6, you've got a pair of alternate exterior angles. So those had to be congruent or equal for those guys to be parallel L and M. So set those two equal to each other. 7, those are a pair of alternate interior angles. So set them equal, solve for X, that'll make L and M parallel. Number 8, these are a pair of alternate exterior angles. So set them equal, solve for X, you'll get your parallel lines. Number 9 is tricky because number 9, this is a pair of angles called, they're same side exterior, which we don't have. So what we have to do is instead say, well, what does this angle kind of correspond with? Oh, it corresponds with this angle here because it's vertical angles. So this is actually 5x plus 19. This guy here also corresponds to this angle here because it's vertical angles. So what these guys really represent are a pair of consecutive interior angles. So we can add these up and set them equal to 180 and solve for X. And then 10, they're just again straight up a pair of consecutive interior angles. Add them up, set them equal to 180. Okay. All right, so here we go. Proof. Provide a reason for each statement in the proof of theorem 3.7. 1 and 2 are complementary. BC is perpendicular to CD. Prove that BA is parallel to CD. So this first one is just a given. Okay. And then this is the one we don't really use that often, that I'm guessing in class a lot of people struggle with. Why would I know that ABC is 1 plus 2? Well, that's the angle addition postulate. Okay. And then 1 and 2 are complementary. Well, that was given. And if they add to 180, once you know that, that's the definition of complementary. For step 5, hey, I knew 1 and 2 added to 90. I know ABC equaled 1 and 2, so I'm going to replace that. That's substitution. Okay. And then, hey, look at that. BA and BC are perpendicular. Why? Because they form a 90-degree angle. That's the definition of perpendicular. And then, okay, we had theorem that said if two lines are perpendicular to the same line, then they have to be parallel to each other. So if two lines are perpendicular to the same line, then parallel. Since BA is perpendicular to BC, and BA and CD are both perpendicular to BC, they have to be parallel to each other. Okay. All right. And then the last one I'm going to look at, last few, yeah, I got about a few more minutes here, from the back of the worksheet that we did in class. If two lines are cut by a transversal so that alternate interior angles are congruent, because that's what alternate interior angles are supposed to be, lines are parallel. If two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. If two lines are cut by a transversal so that alternate interior, alternate exterior, or corresponding angles are congruent, then lines are parallel. That's actually all three. It said give the choice or choices. So all three of those guys are congruent. Works. And then number 10. Number 10 is really a lot like the previous one, kind of prove that these guys are parallel given a bunch of information. So here's what we know. We know that 1 and 2 are congruent to begin with. Okay. And we know that L is parallel to M. What we're trying to do is prove that A is parallel to B. Well, going through the proof here, I know that L and M are parallel. That means then I know that 1 and 3 have to be congruent because they are corresponding angles. And then look, if 3 and 2 are congruent as well, they are alternate exterior angles. There we go. That's how I can prove lines are parallel. I've got a pair of alternate exterior angles that are congruent. Therefore, the lines must be parallel. So now it's just a matter of kind of going through and saying that. So why do I know L and M is parallel? Well, it's given. Why do I know that 1 is congruent to 3? That is the corresponding angles postulate. Oops. Okay. Why is 1 congruent to 2? That was given. Okay. And then if 1's congruent to 3 and 1's congruent to 2, how can I say 2 and 3 are congruent? Transitive property. And then I can say A is parallel to B by the alternate exterior angles converse. Okay. There we go.